Have you ever wondered that is there the reason where space-time and reality are stranger than friction? We, the member of physics Boffin, are here to answer that question.
So now we, the team of Physics Boffin, will be discussing about the black hole.
Black hole is a region of space-time having a gravitational field so strong that no matter or even electromagnetic radiation such as light can escape through it.
How are black holes formed? Before knowing that, black holes are one of the strangest things in their existence. Where do they come from? What do they look like? Before knowing that, we need to know about stars. Stars are incredibly massive collections of mostly hydrogen atoms. They collapse from enormous gas clouds under their own gravity. In their core, nuclear fusion crushes hydrogen atom into helium, releasing into a tremendous amount of energy. This energy, in the form of radiation, pushes against gravity, maintaining a delicate balance between two forces. As long as there is fusion in the core, the star remains stable enough. But for the star with the way more mass than our own sun, the heat and the pressure of the core allow them to fuse heavier elements. Until it reaches critical amount, the balance between radiation and gravity is suddenly broken. The core collapses. Within a fraction of a second, the star implodes, and then it starts to move about a quarter of the speed of light, feeding even more masses into the core. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole. So now you might have questions like, how does an object approaches a black hole? To know that, first you need to know what is an event horizon. A event horizon, or as well as we call it, point of no return, is the boundary of a black hole beyond which light cannot totally escape because the gravitational pull of the massive object becomes so high as to make escape impossible. Any object approaching the event horizon never actually crosses it from an observer's point of view. Instead, it becomes more and more redshift as time leaps. This means the wavelength of the light coming from object becomes longer as it moves away from the observer. This phenomenon of shifting of wavelength is known as Doppler effect.
Okay, now talking about types of black hole. Number one, stellar black hole. Stellar black holes are the most common types of black hole and are generally 10 to 20 times more massive than the sun. The next is supermassive black hole. Supermassive black holes are generally found at the center of the galaxy, and it is expected that our Milky Way galaxy has also one. Supermassive black holes are usually 1 million times more than that of the sun, but it is also expected that some distant galaxies have as big as 21 billion times as the mass of the sun. The third one is intermediate black hole. Intermediate black holes are formed when the oldest stars in the universe collapse, and till now, only one of its kind exists in theory. The last one is miniature black holes. Miniature black holes are as wide as an atomic particle. They have a mass of about as of a Mount Everest, and they are considered to be about 13.7 billion years old, formed soon after the Big Bang. Now talking about the gravitational force of the black hole. A black hole is a region of space-time where gravity is so strong that nothing, no particle, or even electromagnetic radiation such as light can escape from it. Black holes are very dense cosmic objects that curve space so much, leading to an unknown singularity point that even light cannot escape through it. So why are black holes dense? When a star dies, the outer mass of it squeezes into a small space, making it denser, causing it to attain a strong gravitational force. Now comes the death of black hole. A black hole dies due to Hawking radiation, that is, evaporation of black hole. When particles escape from a black hole, the black hole loses a small amount of its energy and therefore some of its mass, which can be calibrated from the Einstein's energy mass equation, that is E equals to mc square, which is why black holes have a finite lifespan.
Scientists have agreed that all the stars in the universe are shrinking and will eventually disappear. Like the sun in our solar system, every second loses about 4 million tons of mass. After this thought, the scientist raises the question that what makes the sun mass continue to decrease? Earth will once you know if the sun is being replaced by the black hole, there will no be life. Then what are the events that would happen on the Earth? Actually, what happened was not that the Earth and other planet would suddenly disappear and disappear. Yes, but in this universe, there would be only losing light sources. Before we go into the discussion, we have to assume that these black holes has the same mass as the sun, neither bigger nor too small. With the same mass as the sun, the movement of the planets around it will remain in its orbit. If it is true that a black hole has a mass like a sun, then only objects that are in a radius of 1718 kilometers will be sucked into the black holes. Earth freezes. After the sun is replaced by the black hole, the Earth and all the planets will lose their light source. This will lead to various events that end in the extinction of life. Well, the first thing that happens is that the atmosphere on Earth will rain like a liquid and will freezes. Earth will experience a phase called thermal equilibrium, which makes the surface condition filled with ice and has a very cold temperature of around minus 200 degrees Celsius to minus 270 degrees Celsius. So with that temperature, of course, no living things will survive unless there is sophisticated technology capable of providing a source of energy like the sun. And the question arises in the last, would the sun become the black hole? The good news, scientists categorize the sun as a dwarf planet, so the sun can never explode and evolve into the black hole because of its relatively small masses. Technically, black holes could form from stars that only have dwarf mass like our sun. To become a black hole, the sun must have at least the mass of star Betelgeuse. And as you know that uh, Betelgeuse will soon explode and will never become a black hole. In the conclusion, we can say that, well, so we can conclude that if the sun is being replaced by our sun turns into a black hole, there is no difference. Life will not last in our solar system, or even our solar system will disappear because of the black hole swallowed it.
What happens if any person fall into a black hole? Would you dare to jump into a black hole? For a supermassive black hole, such as found at the galaxy's center, an astronaut may cross the event horizon. The event horizon of a black hole is the point of no return. Anything that passes this point will be swallowed by the black hole and forever vanish from our known universe. So an astronaut may cross the event horizon without noticing any squashing and pulling. For small black holes, whose source child radius is much smaller or closer to the singularity, the tidal forces would kill even before the astronaut reaches the event horizon. You would most likely not survive either a small or large black hole. Remember, light cannot even escape a black hole. That is why it is called a black hole. From an outside perspective, time would slow down as you move closer to the center of the black hole. Time and space begin to wrap and stretch as they are pulled towards the center of the black hole. This means that you too would wrap and stretch like spaghetti, like noodles, by the gravitational gradient from head to toe. The bending and stretching is called spaghettification. The reason this happens would be that the gravity force exerted by the singularity would be much stronger at one end of the body than the other. If any person fall into a black hole, feet first, the gravity at there would be much stronger than at their head, causing the person to be vertically stretched. Someone outside the black hole would see your body begin to stretch and begin like a spaghetti noodle and bend like a spaghetti noodle. As you approach the edge of the event horizon, you will freeze in space and time. You will appear to be unmoving and stretched like a noodle forever. However, time becomes strange as you get closer to the event horizon or at the end of black hole before the large pit. In your eyes, as the one who is falling into the black hole, you would experience time normally. Additionally, once you reach the event horizon, you may survive. To outside observer, you are gone. However, in your perspective, you are alive and well. The issue in the case is that once you pass the event horizon, you cannot turn back. While you are alive and well within the black hole, you may never return. To return would mean to travel against time and space. We all know that you cannot time travel into the past. Light cannot even do this. To outside observers, you are dust. You may not tell them that you are alive in your new reality within the black hole because you cannot travel against time. So this much for today, as the team of physics Boffin did great about explaining the black holes. So black holes are where God divided by zero. That's by Subramanian Chandrasekhar, 1910 to 1995. Thank you.